In this collection of videos, we are going to talk about list comprehension. In our previous collection of videos, we introduced lists and tuples and dictionaries, lists being the biggest item that we were really studying from that collection of videos. And if you'll remember, lists are Python objects that we use to keep track of many related variables. In fact, sometimes a lot of related variables. And this begs the question, if I'm going to be keeping track of a whole lot of variables, how am I going to smartly and efficiently get the computer to create the values in that list itself so that I don't have to go through and enter every single value in the list myself by hand? So at first sight, this seems like a big problem and like something that's maybe not very well thought out. One method that we can use in order to create lists of numerous objects that are related somehow is to make a combination of looping mechanisms within Python and list methods. And the combination of those two things working together can help us to create these lists. In fact, in many other programming languages, this is the only way to populate a list with numerous entries without having to enter them in yourself. So we're going to use an example saying maybe we want to generate a list of census years starting in 1900 and going up into the present day. So that would be measured by decades. We want a list of all those things without typing them in ourselves. What we might do is start with a blank list with no entries in it, and then create a loop. And that loop is going to range over the time frame that we want to consider. We're going to start at the year 1900. We're going to have to go up to the year 2021 because Python is a little wonky and is inclusive at this value and exclusive at this value. So to go one higher than you might think you would have to go. And we can add this additional function to the end of the range command that's telling us to take steps of size 10 within this loop. So instead of doing 1900, 1901, 1902, all the way up to 2020, we'll instead go 1900, 1910, 1920, exactly like we want to do. So this range is stepping over the right values. And what we could do is go to our list decades and append that particular I value. As I begins at 1900 and adds 10 to itself every single time, we add that value to the decades list with the append method. And then in the end, if we ask Python to print the decades list, it shows us those values that we're looking for. So this is a perfectly acceptable method for how we could populate a list with some looping in order to make it so that there's less typing on our end. It's in fact the way that this was done for a long time and is still done in other programming languages. But what's really amazing about Python is that this is a process that's done so much in computer science that Python has a special syntax called list comprehension just for combining the creation of lists with loops that can all be done in a single line of code, which is really nice. We'll go through the syntax for list comprehension in just a minute, but the syntax over here on the right is at least showing you how we have lists involved. We see that same syntax that we saw in the last collection of videos where we have the name of the list created over here, an assignment operator with the equal sign, square brackets, just like we would with a list, and then somehow there's this looping notation going on inside the list. So we'll go through the syntax in a moment, but if you were to enter the code that you have right here, just one line of code, this is an example of list comprehension, and you can see that the output values over here for the thing called decades is precisely equal to the set of output values that we got in the previous slide with fewer lines of code. So let's now take a look at that formal syntax for list comprehension. as we saw when we were creating lists, we're going to put the name of the list we're creating over here on the leftmost value, an assignment operator, and then the square brackets that we use to define a list. So all of those parts of the syntax for list comprehension come from the syntax for just creating any old list. In between those square brackets are three components. There's the expression, the member, and the iterable. Now remember that Python lists are for keeping track of many variables that should have something in common. Expression is aiming to formalize and write down a precise equation for exactly what it is that the values in your list have in common. Member is just going to be the name of another variable that's going to be stepping through your iterable, and generally this variable that represents the member quantity will be involved in your expression and also will be involved in the iterable. So whatever letter or variable name you create to represent the member should also occur here and here, generally speaking. And last but not least, iterable is the part that you're looping through. So it's something that you can step through one piece at a time, like a range, a list, a dictionary, maybe a string. It's something that has positions 0, 1, 2, 3, 4, and so on. As member, one by one steps through the values in the iterable. So to go back to our previous example, we created a list with the name decades, and we assigned it the value of the list that follows the pattern in this sense. The expression is this 1900 plus 10 times I. That's the mathematical equation here that describes the values that will be occurring in my list. We want them to be decades starting at 1900 and going for a certain amount of time. So the 1900 plus 10i is the expression. We then have the Python reserved word for. My variable name that is member is just going to be I for iterator, because this I variable is going to be stepping through one by one the values in this iterable, this range, which we kind of think about as the values 0, 1, 2, 3, all the way up through one less than this number, which is 12 here. Let's end this video with one more example and some things to think about before we begin the next video. Let's imagine that our task is to create a list of prime numbers between 1 and 100. Now for technical reasons, 1 is not considered a prime number, so I'm really looking at the list from 2 to 100. And it's a fact that you could learn if you are studying mathematics that in order to find the prime numbers, one thing we could do is just list out all the numbers from 2 to 100, and keeping 2, 3, 5, and 7, which are our first examples of prime numbers, we could eliminate anything greater than those values that is a multiple of those values, and when we're done, what we'll have is a collection of the prime numbers between 2 and 100. So one possible way that we could solve this problem is we could make a couple of lists. A list that contains multiples of 2, a list that contains multiples of 3, one for multiples of 5, and one for multiples of 7. And we could combine all of those numbers together and just walk through our prime numbers and cross out any value that occurs in that not prime list. So one little bit at a time. If we wanted to create a list that contained multiples of 2 that were bigger than 2 but less than or equal to 100, we could create a list that we call mult2 using our list comprehension notation. So what we want to make a list of are multiples of 2. They're 2 times something. That's the expression we're looking for here. We then want the something to start at a value of 2, so that the first thing that we put into this list will be the number 4. And we want our variable, our member, here just named I, to start counting at 2, but where do we want to stop counting? Well, the very last value we want I to take on is the value of 50. So I'll need to go up to 51, since our range function is not inclusive here, in order to end at a value of 2 times 50, which is 100. And if I build this list molt2 in this way, this is the output that I get. I could generalize that a little bit to create something called molt3, where the expression is just 3 times I. I'm still using that same variable I, although I could call it something else if I so desired. And the range that I'm looking at starts at 2 and ends at approximately 100 divided by 3 plus 1 more. Again, because that range is not inclusive at the end. So I leave you with these tasks before we begin the next video. See if you can write down the syntax for 2 more lists, one called molt5 and one called molt7, where we're going to hold the multiples of 5 and 7 in those lists respectively, so that ultimately we can combine these lists to look at all of the not prime values. The second task to think about is, once I have these 4 lists, molt2, molt3, molt5, molt7, how can I put them together into a larger list called not primes? And then truly just a thinking question to motivate what we'll do next is think about how would we then take one list and filter out the values in that list that are not in this other list, not primes, that we've just created. You may not have an answer to that question just yet, but think about it and see what you can come up with.